everyone, this is Nick from App Dev Rocks. In a previous post, we looked at the string templates introduced in ES6. So today we're going to dig a bit deeper and see how string templates are working under the hood and how we can expand upon them with tagged template literals. So before we look at creating our own tagged template literals, we need to understand how ES6 string templates work. Many of the updates added in ES6 are what's referred to as syntactic sugar, which is basically a shorthand way of working with existing behavior. So we'll start by defining a couple of variables. First, I'll define a variable name and set that to Nick. Then I'll define a variable role and set that to developer. And down here, I'm going to console log out my name is, and then pass in my variable for name. And I'm a, and then we'll pass in the variable role. There we go. Now when I run this, what we get is the full string. My name is Nick, and I'm a developer. So you can see that it's substituted these variables within our string template. So the name variable was inserted here, and the role variable was inserted here. So when one of these string templates is declared, what happens is the string parts, that's here and here, are combined together with the variable parts here and here. And in the end, it produces a string. To get a better picture of what's happening here, let's create a function that does what this string template is actually doing. So what we have here is kind of an example of how the string template actually parses the combination of strings and variables. So imagine that we have this function which is receiving a parts parameter. So this is an array of all the string parts, and then this vars variable which contains all the variable parts of a string. So where we inserted the name and the role. And then what our function does is it takes this parts array and reduces it. If we look at our tag template literal function here, this example function, first it's going to take an array of parts. So imagine this would be every static string part, not the variable parts, just the fixed strings. Those would go here. And we're using the spread operator to take all those additional arguments and join them into this one single array. Next, it's going to take our string parts and it's going to reduce them. So what happens with a reducer is each item in the array, it's going to iterate through each one, and it's going to reduce it down to a single value. So this function that we pass to it is going to receive first the accumulator, and this is the value that is going to keep expanding each time we iterate through one of these parts items. And then finally an I, just to indicate the index that we're at in the iteration. So next, in our function, what we're doing is we're returning the combination of the accumulator, which is whatever previous value we had while we're iterating. We're combining that with whatever index we're at minus 1. So one variable behind whatever index we're on this particular iteration. And then finally adding in the part. So you can imagine the first time we go through this, accumulator will be empty. We'll be at index 0, so this would be -1, so that won't exist either. So the only thing that's returned is that particular string part. But then the next iteration it goes through, this accumulator will be populated with our first string part, and to that we're going to add the variable. Since the index would be at 1 now, 1 minus 1 is 0, so we'll be taking our first variable and adding that to our accumulator, and finally the string part will be added to that. And once the iteration is complete, where it's iterated through each of these string parts, it's going to return that out. Now, if I give this function a name, we'll call it example tagged template. So first, I'll bring back our variables and the string template we had. And now I'll show you, using our example function, what it would look like when it's called. So the first variable is an array of all the string parts. So what we can do is literally take each string and pass it into this array down here. And one of the funny things about the way that these string templates work is that if it ends with a variable at the end and there's no more string after that, what it will do is it will simply pass an empty string as the last element in the parts array. So that's it for our string parts. You see we have 3 here. And now for the rest of the values, we're using the actual variables here. We can take the name, pass that here, and finally take this role and pass that here. So just like our example function up here, the first element is a parts array, that's string parts, and we have that here. And then the rest of the elements are all the variables, which we have name and we have role. And remember, because we're using the spread operator, we take all those additional arguments and combine them into one value, an array of arguments here. So now, if I run this function, first let's log it out to the console. So first I'm going to comment out my original console.log with the string template, and instead I'm going to console.log out our example tag template function, which is doing essentially the same as our string template. So let's try running this and see what we get. So you can see the output is exactly the same. So our function here is doing the exact same thing that's happening behind the scenes when we run this. I'll uncomment this line, and we can see the output is exactly the same. Each one, the string template and our example tag template function, is doing the exact same thing. So I'm going to keep my example function here for a moment, and I'm going to remove this down here. We won't need that now. But this example function, we can use that as a tagged string template. I'm also going to take my string template here and just assign it to a variable. We'll call it output. This will just make it easier to see when I turn this into a tag string template. So the syntax of a tag string template is pretty simple. So here we have our string template, and to make it a tag string template, we just put the name of our function at the beginning, right before the first tick mark. So we can see example tag template, that's our function, and then immediately we have the string template. Now what happens when you run this, because our function is basically doing exactly what a normal string template does, there won't be any difference in our output. So if I run this, you can see we still get the same output. My name is Nick and I'm a developer. But what we can do now is change the behavior of our tag template function up here. So what if we took the variable here? So remember, this is each variable, so name and role, and we told our function to convert it to uppercase. So now when we run it, you could see that the string template, it transformed our variables, Nick and developer, into uppercase. So this here is probably not the most useful tag template function you can use, but it kind of shows you what you can do with tag templates. So for example, what if we wanted to take our string template and have it automatically wrap every variable passed to it with some HTML. So we'll imagine that we have a CSS class called highlight, and we're going to wrap each of our variables. We'll get rid of the two uppercase. And we'll wrap each variable with this span. And just for good measure, we can use template literals here. $, open curly brace, close curly brace. So now what's going to happen when it iterates through our parts, every time it gets to a variable, it's going to wrap that variable in this span, which has a class of highlight. So now if I run this, you can see that we have the same output, but this time the name variable, Nick, is wrapped in a span with a class of highlight, and the role variable of developer is wrapped in a span with a class of highlight. So this kind of shows you the flexibility of using tag templates and how you could build up your own library of tag template literals and use them in different situations. So we can even take this a bit further and handle non-string variables such as objects. So let's remove these variables here and imagine we have a car object. So this car will have a make of Toyota and a model of Corolla. So let's remove this part and kind of reset it back to the way it was. So now imagine when it runs this. So let's change this template literal here to something more suitable for a car. So we'll take the car and do for sale. And now in our function up here, what we can do is take whatever variable is passed in, and in this case, car is an object. So we can work with this just like any other object. So let's say we wanted to take the make. If we run this now, you can see that it says Toyota for sale. So we passed in the car object, but because we're using this tagged template literal, it's taking the make property of the variable passed in. And we passed in car, and its make is Toyota. And that's why it substituted car for Toyota. Because if we didn't do this, instead we'd get something like this, which is probably not what we want here. Or we could change make to model and run it again, and we can see that now it says Corolla for sale. So this is great. But what if every variable isn't a car object? What if we want to be able to pass different kinds of variables? So sometimes it might be a car object. Sometimes it might be just a plain old string. How do we handle that? So since this is just a function, we can actually handle that right in our function. So first, I'm just going to change this to open and close curly braces. That way we can return some value down here. I'm going to move this down here. So the first thing I'm going to do is assign our template variable here like this. This will just make it easier to work with. Then we're going to determine the value of the variable here. So what we can do is we can use type of to check if our variable in this particular iteration is an object. And if it is, then we can access the make property of that object. And if it isn't, then we can assume it's just a plain old string, and we'll just return it directly. And then finally, at the bottom down here, we'll take our var variable, put that in here. So now each time it iterates through, first thing it's going to do is it's going to grab that variable. It's going to check if that variable is an object. If it is, it's going to access the make property of that object. But if it isn't, it's just going to treat it as a string and pass it directly to this var value. And then finally, we join everything together just like we did before. So now, if I run this function, we can see that our original function still works. We passed in the car object, and it's giving us the make property. And if we expand our tag template, let's say we wanted to add in a state value. Let's set state equal to Rhode Island. Now, if I run this, you can see that car is still handled like an object, so the make property is pulled out. But then state, because it's a string, it's just returning it as a string. This allows us to have a function which is infinitely flexible. We could add any number of conditions in here to handle all kinds of different values that could be passed in. Hopefully this gives you a deeper understanding of string templates, as well as provide some ideas on how you can use tag template literals in your code. Let me know in the comments below if you found a way to leverage the power of tag templates, what is working for you, and how you're using tag template literals. Thanks again for watching. I hope you enjoyed this video. If you got a lot out of it, give a thumbs up below. If you want to see more videos like this, remember to subscribe. Thanks again, and I'll see you in the next lesson.